Okay, this is on equivalent trig expressions. But before we go through the trig expressions, I want to go back and review the steps in factoring, because you'll be using all the steps in factoring. So, and I think we probably reviewed these in pre-calc, but that's been a semester. So we'll go back, refresh your memory, review the steps in factoring. Remember, factoring is one of the key methods in solving like quadratic equations. Okay. First step when you factor is to look for common monomials. Remember, a monomial can be a number, it can be a variable, it can be an indicated product of a number and one or more variables. So if I give you something like this, 2x squared minus 50, and if I ask you to factor that, what's in common in both terms? A 2. And you can use one set of parentheses, and you figure out, what do I have to have so that when I multiply this back I get the original? And basically 2 divides into both those. Okay, so and remember, in factored form you take out the greatest common factor, and you can't have anything left in common inside the parentheses. There can't be anything in common, and you should be able to multiply this back to get the original. Okay, so that's the first step. It might be a variable in common, might be a number. Okay, so look for common monomials. Second step, look for the difference of two squares. Look for the difference of two squares. In that pattern, okay, most of you will remember the pattern a squared minus b squared, difference of two squares. And that'll factor into a plus b times a minus b. One plus sign, one minus sign. I don't care if you write it a minus b, that quantity times a plus b, it's the same answer. Okay, so if I go back up to this one, I can take this an extra step and say x squared minus 25. I know I need an x and an x. I need one plus sign, one minus sign. And 25 is a perfect square of 5. Okay, so now that's factored completely. Okay, so difference of two squares. Enough examples on that one? Okay, just refresh your memory. Third step in factoring, look for trinomial squares. Okay, look for trinomial squares. Okay, trinomial squares, the pattern looks like this. A squared plus 2ab plus b squared, and you can write it. You know, you need an a times an a b times a b, and the signs are both positive. Okay, or you can also say a squared is a perfect square of a, b squared is a perfect square of b. If you multiply those two together, ab, and double it, do you get that middle term? Yeah. So most of the time they're going to write it a plus b quantity squared. So an example of that. Say I have x squared plus 10x plus 25. There's nothing in common. It's not the difference of two squares. Then you go to the trinomial squares. X squared is a perfect square of x. 25 is a perfect square of 5. If I multiply those two together, I'd get 5x and double it. Do I get 10x? Yeah. And this tells you the sign inside is positive. So you write it x plus 5 quantity squared, or that's the same as x plus 5 times x plus 5. Okay. The other trinomial square looks like this. A squared minus 2ab plus b squared. For it to be a trinomial square, that last term always has to be positive. But a squared, this will factor into a minus b times a minus b, or a minus b quantity squared. Example of that one, say I gave you x squared minus 16x plus 64. x squared is a perfect square of x. 64 is a perfect square of 8. If I multiply those two together, I'd have 8x and double it. Do I get that middle term? 16x? Yeah. And this tells you the sign inside is minus. So it's x minus 8 quantity squared. Or you can write it x minus 8 times x minus 8. Okay? Okay, fourth step. Hope these are refreshing memory. Fourth step is look for trinomials. And this is what I call the Sherlock Holmes. You look for the clues in the signs when you're factoring and the clues in the numbers. Okay, so if I had like x squared plus 10x plus 24, okay, I still, is there anything in common? No. All the way across? No. Difference of two squares? No. Trinomial square? No. 24 is not a perfect square. So now, I look, first thing, this is like reverse FOIL. Some of you learn first, outer, inner, last when you multiply things out. It's the reverse of that. So first thing I look at is the signs. When and I know I need an x times an x to get x squared. When I multiply these last things together, they have to be positive. So this tells me it's a positive times a positive or a negative times a negative. So this tells me the signs are alike. This tells me what they definitely both are. They have to be a positive times a positive. They multiply together to give you 24. If this is a plus sign, you say they add together to give you 10. Okay, so you go through all the factors of 24. 1 and 24, 2 and 12, 8 and 3, 6 and 4. You finally get down to 6 and 4. Okay? And you can check, when you multiply this back, that's x squared plus 4x plus 6x would be plus 10x plus 24. Okay? Other possibilities in signs, examples like, say I had x squared minus 2x minus 24. Okay, I know I need an x times an x to give me the x squared. When I multiply this last thing together, it has to be a negative 24. So one's got to be positive, one's got to be negative. I don't care which order. One positive, one negative. Okay, they still multiply together to give me 24. If this is a minus sign, they differ by 2. Also, this tells me the signs are different. They're different signs. Okay, they differ by 2. And this is the sign of the larger one. Do you remember going through all this like in Algebra 1? Would have been like in Algebra 1. Okay, so end up like 6 and 4 again. And the sign of the larger one is 6. So 6 goes with the negative. And you can check just the middle term. If you check just this, it would be plus 4x minus 6x would be negative 2x. Yeah, that checks. Okay, so that's like what I call the Sherlock Holmes. Look at all the clues in the signs. Okay. Now, next step is the fifth step. This is your Algebra 2. Okay, you should have spent plenty of time. This will come up from now until your math career is over. It'll show up in Calc, and then 2 months later it shows up in Calc. Might be a month later, it'll show up in Calc. It's one you have to have memorized. Okay. Look for the sum or difference of 2 cubes. And you did not get this until you got to Algebra 2. So everything up above is Algebra 1. Okay? Okay, the pattern. A cubed plus b cubed. If that's a plus sign, the sign inside the first set of parentheses is the same. It's plus. And then a squared minus ab plus b squared. So I already remember if this is a plus, then this is a plus, this is a minus. The last sign is always positive. The other thing is, notice there's no 2 in front here. A lot of people think, oh, because there's a 2 in front here, that there's a 2 in front. No. Okay? The other pattern is a cubed minus b cubed. I just remember if that's a minus, Then the sign inside the first set of parentheses is also the same. It's minus. And then it's a squared plus ab plus b squared. When you factor cubes, you always want to figure out what's the a and what's the b. So let's look at an example. Okay, say I give you 8x cubed plus 125, and I want you to factor that. Don't factor it with the 8. Figure out 8's a cube of what number? 2. So I can rewrite this as 2x quantity cubed. 125 is a cube of what number? 5. So this is my A, this is my B. Okay? Then I can write down the pattern and it's plus. So this is the easiest way to do this. Write down the pattern, okay, and then put in, this is my 2x cubed plus my 5. Okay, so now you can factor this back. Your A is 2x, your B is 5. If you take 2x and square it, it would be 4x squared. Your A, B, you just multiply them together, it would be minus 10x. And then plus 25. Okay, and that's as far as you can go. Okay. No, it just fills back. Once you figure out this is your A and this is your B, it just goes right into that pattern. Okay. Okay. Let's try another example. Let's say I gave you 27x cubed minus 64. Don't try to factor it like that. You say, okay, 27 is a cube of what number? 3. And x cubed is a cube of x. 64 is a cube of what number? 4. So now you know your A is 3x and your B is 4. So write down the pattern. So it's A cubed minus B cubed. If that's a minus, the first sign inside's minus, the second one's plus. Okay, and now this would be 3x quantity cubed minus 4 cubed. So this would be 3x minus 4, and this would be 3x squared would be 9x squared. And then AB would be, multiply them together, would be 12x. And then square the 4 would be 16. Okay? So you should end up with 3x minus 4, that quantity, times 9x squared plus 12x minus 16. Okay? Okay, so that was Algebra 2. Okay, then the last step, step 6, is factor by grouping. You probably didn't do a lot with this, but you did some. Okay, and I'm seeing this one show up more. Let's say I give you this example: 3ab minus 20cd minus 15ac plus 4bd. Now, if you look at all 4 terms all the way across, there's nothing in common. Okay, so you group it, and you don't necessarily have to group it like I do, but you got to look for what's in common. Okay, like I grouped these two together, the 3ab and the 15ac, and I grouped these two together. Okay, so I would have grouped 3ab minus 15ac minus 20cd plus 4bd. So I grouped these two, and then I would probably change this minus 20 to plus a negative and group those two together. Okay, now in this, what's in common? 3, what else? 3a. What's left inside? b minus 5c plus. Now in this one, what's in common? And I want to try to get this as the common factor. Okay? So 4D. I take out a positive 4D, and now what's left? And that's what I want. Plus B. Okay? And now here's kind of the problem that they're giving them, like in Algebra 1 or something. They will give us this line and say, okay, what's in common between this term and this term? What's in both of them? B minus 5C, right? Take that out. Take the B minus 5C. And what's left inside the brackets? What's left out of this term? Yep, the 3A, and then I'd have the 4D plus 4D left inside the brackets. Yep. Okay? And that's factored completely. Now, here's the error. People do this. Now, without that, I'm just taking the 5C times both those. So that's wrong. So you got to make sure you have the grouping symbol. Okay? Okay, now, how are we going to use this in Trig? Okay? So go back up to the top. Everywhere you see an X, I'm going to put in a trig expression. Okay? So, example. Instead of this, I'm going to do 2 sine squared theta minus 50. What's in common? 2. What's left? Sine squared theta minus 25. Inside, that's a difference of 2 squares. I'm going to factor it into sine of theta plus 5, sine of theta minus 5. I'm still factoring. I'm just using, instead of an x squared, I'm using a trig function squared. Okay? So if it ever bothers you that there's a trig function out at the side, do the scratch work. Don't do it in the middle of the problem, but outside you could replace it with an x or a y or something like that. Okay? Same thing like on, well, I already did that. So, like on this one, it'd be like, say I did cosine squared theta plus 10 cosine theta plus 25. That's going to factor into cosine of theta plus 5 quantity squared. Okay? So it's just going to have trig functions in there instead of x's and y's. Okay? Okay, now I want to go through some examples on the homework. Okay? Okay. In the directions, it will say that in this type, it will say convert the first trig expression, and we're actually going to make it an equation to the second. The author uses a semicolon. I want you to switch it to an equal sign. Okay, so an example. These are going to be fractions. So up in the numerator, sine cubed theta minus 64. Use the horizontal fraction bars, not the diagonal ones. And it's all over sine squared theta minus 16. The author would have a semicolon right here. I want you to make it an equal sign. Up in the numerator, sine squared theta plus 4 sine of theta plus 16, and it's all over sine of theta plus 4. Now, this also goes back to geometry. Remember in geometry when you did 2-column proofs and you did left side equal right side, left side, left side. You worked with that left side all the way down until you proved they were equal, and then you write the right side. You don't have to write that right side on every step. Do it on the first line and the last line, and there ought to be equal signs all the way down. Okay? Okay, so look at just this top part. Do you recognize that? Difference of 2 cubes, right? So, now take a minute and factor that. Okay? I'm going to Okay, so let's go back and factor that. If you factor that, it should factor into sine of theta minus 4 times the sine squared theta plus 4 sine of theta plus 16. Okay? Then the bottom, that you should recognize as the difference of two squares. Factor that. You can factor it into sine of theta plus 4, sine of theta minus 4, both quantities. Okay? I don't care which one's first. I don't care the plus or the minus. Which one's first, doesn't matter. Now, I always tell people on these problems, don't get too slash happy. Okay? Slashing everything out. The only time you can slash something out or reduce it is if there's a time sign, and there is a time sign right here and a time sign right here. Like I can't divide this sign out with this sign, okay, because there's plus or minus signs around it. But I can reduce this whole quantity divides out with this whole quantity. Those quantities are the same. And when they divide out to 1. And don't say they cancel, because canceling means subtraction. And now if you look, you're actually at your answer. Okay? Left side equals the right side. Okay? So then you repeat it. So you just prove the left side equals the right side by factoring. That's the only time you have to write down that right side is on the first line and on first line and the last line. Does that look all right? Good. Okay. Second example. Okay, say I give you the quantity 1 minus cosine of theta times the quantity 1 plus cosine of theta. And by the way, they're going to use all the angles that we talked about in the first chapter. Like they're going to use thetas, they will use betas, they will use alphas, they will use mu, they will use lambda. Remember, those are all on page 16 if you need to go back in your book. That gets you ready for all the fraternities and sororities over there. Okay? And say this equals sine squared theta. Now, when we're working these problems, we're working left side all the way down. We're not working left, right, no. Left side all the way down. Okay? I'm just picking one side. That way it's much easier when we check. So on this one, that's already factored. You can't do any more factoring than that. What you actually need to do is FOIL it. Multiply it back. What are you going to get? If I multiply this back, 1. Multiply this back, plus cosine of theta. Multiply this. And some of you may have seen that was the difference of two squares factored. So the plus cosine of theta minus cosine of theta drops out. Okay, and you're back to 1 minus cosine squared theta. You agree with that? Okay, and then on your card, look on your card. That's why you all, from now on you want to have that card out. Okay? What is 1 minus cosine squared theta on your card? You should find it on your card. Sine squared theta plus cosine squared theta equals 1. Now, what's 1 minus cosine squared theta? Sine squared. So you'd have sine squared theta equals sine squared theta. Bring down the right side and you're done. Okay? Okay, if you look on your card, you got this. Sine squared theta plus cosine squared theta equals 1. But what we did in today's assignment was there's actually two other formulas there. Okay? Solve this. Like if you subtracted this, if you took this cosine squared over to the other side, right, you'd have 1 minus sine squared, or excuse me, I said that wrong. You'd have sine squared theta equals 1 minus cosine squared theta. If I took that cosine squared theta over to the other side. Okay. So for 1 minus cosine squared, I can sub in sine squared. Does that make sense? Okay. What's the other one on this? No, just on this one. How, if I subtracted sine squared? Yep. Okay. Okay. Third example. Up in the numerator, 9 sine squared theta minus 24 sine of theta plus 16. It's all over 9 sine squared theta minus 16 equals 3 sine of theta minus 4, and it's all over 3 sine of theta plus 4. Okay, now factor that left side. Is there anything in common all the way across on the top? No. Difference of two squares? No. Is it a trinomial square? 9's a perfect square of 3. Sine squared is a perfect square of sine. 16's a perfect square of 4. If I multiply those together, I'd get 12 sine of theta, and if I double it, do I get 24? Do I get that middle term? 24 sine of theta? Yeah. And this tells me the sign that's inside. Now, I can write it like this with a squared up here, or I can write it twice. I'm going to write it twice because that's how I'm going to reduce it. And then the bottom is actually a difference of two squares. 3 sine of theta, I need a 3 sine of theta, I need a plus 4 and a minus 4. It doesn't matter which order. Okay, now you can reduce it. And it doesn't matter, this quantity is going to go out with either one of the top ones, I don't care which one. And it reduces to 1. And now you're actually at your answer. Okay, so on all these problems, factoring is a key. That's why I wanted to go back and review it. And then bring down that right side. And these will all work. It's not a case of they won't work or they will work. They all work. Okay? Okay, any questions on that one? Okay, now they're going to change the directions. Okay? In the directions it will say simplify each expression. Okay, simplify each expression in terms of, now, it will say in the book in terms of, and it's going to pick a trig function. It might say in terms of sine, in terms of cosine, in terms of tangent. Okay, the one I'm going to do is in terms of cosine. I'm going to work three problems like this. That means the only trig function that you can have in your answer is cosine. You can't have a tangent or a secant or anything else in there. The only trig functions in the answers for this will be cosine. If they said sine, then that'd be the only thing you could have in your answer, sines. Okay? Now, these are not equations. These are just expressions, and we're going to convert them. Okay, sine of theta times cotangent of theta. Okay, now this, all of this, you're going to use your card. Okay? We want to get to cosine. What's cotangent in terms of sine and cosine? Yep, so it's cosine divided by sine. You should find that on your card. Cotangent is cosine over sine. That's one of the ratio identities. Okay, now this is like over 1. Right, and you're multiplying. Now you can do the slash, divide it out, reduce it. Sine divided by sine, it reduces to 1. So what's left? Cosine. And you're done. That's the only trig function left in your answer. Okay? Any questions on that one? Okay, let's try another one. Say they give you cosecant squared theta minus 1. That quantity times sine squared theta. Okay, look on your card. What is cosecant squared theta minus 1? Cotangent squared, right? So that is cotangent squared theta. And I would probably just leave the sine squared. You can change it if you wanted to, but I'm not going to. Now, you just told me on this last problem, cotangent was cosine over sine. So what's cotangent squared? Yeah, cosine squared over sine squared. Okay, and this is sine squared, like over 1. Now reduce it. Okay, when you reduce it, this divides out. Those reduce. And all that's left is cosine squared. Okay, and that's the only trig function that's left. Yeah, as long as it's just saying, like when it says in terms of cosine, that means, yeah, I could have cosine to the 4th or whatever. It's just that's the only, I can't have a cosine and a tangent in the same problem. Okay? Okay, last example. Number 6. Up in the numerator, 1 plus tangent of theta, and it's all over, oh, I didn't write that very good. 1 plus tangent theta, and it's all over cosine of theta plus sine of theta. Okay, now, I want you to look on your card a minute. On your card you have this, 1 plus tangent squared theta equals secant squared theta. Am I right? Okay, now, is this legal? Everybody look. Everybody looking? Okay, is this legal? Before you answer, okay, let's say I get to a test. I don't know if that's legal or not. So, 9 plus 16 is 25, right? Maybe I should start, let's start this way. 9 plus 16, 25? Is this legal? No. On your card, just because it has 1 plus tangent squared equals secant squared, can I take a 1 plus tangent out? No. Remember everything you did in Algebra 2, when you took something out of the radical, it was because it was multiplied together. But as soon as you put that plus or minus sign in there, so people are tempted on this 1 plus tangent to say 1 plus tangent is secant. No, that's not true. They're like, that's not true. Okay? So, you can't go that way. Okay? But you can go something with that. Remember, we're trying to get everything in terms of cosine. Sine over cosine. Yep, that's the way you want to go. So this would be 1 plus sine of theta over cosine of theta. And again, use the horizontal fraction bars. And like if it's a complex fraction, I usually try to make it a little bit thicker. Okay, and then this is just, you can't simplify cosine, and you can't simplify, and that's another one. Can I take, look on your card, you've got sine squared theta plus cosine squared theta equals 1. So can I take the square root of both sides and say sine plus cosine equals 1? No, it doesn't work. Okay, so that's not true. Okay, so this is like 1 over 1. Look just at this top part. What is the common denominator? Cosine. So this would be cosine of theta. This fraction would not change. If I multiply this by cosine, I got to multiply this by cosine. So this is like cosine over cosine. And then it's all over cosine of theta plus sine of theta. Okay? Add these two fractions together. Right? So I should be able to say cosine of theta plus sine of theta all over cosine of theta. That's the top fraction. Divided by cosine of theta plus sine of theta. Do you agree that this cosine of theta plus sine of theta is like over 1? Okay, now if I invert that and multiply. Now, some of you will be able to see it from right there and see what the answer is. Okay? Can anybody see the answer? What is it? No? 1 over cosine. If you can't see the answer, then you need to rewrite it. Like I would write that first fraction, and I'm going to show the steps, divided by the second fraction. Now you invert this one. Okay, so it would be first fraction stays the same. So that cosine is still on the bottom. Invert that, would be 1 over cosine plus sine. And do you see that this whole thing divides out with this? So the cosine is still in the bottom. You got this 1 up on top, cosine in the bottom. Now, go back and look at this for a minute. Look at this fraction. Now, can you see it to get to there? The two numerators divide out. This stays in the denominator, right? Yep. Okay. Everything's in terms of cosine. Okay. Okay. That should be enough to get you started. Remember, every place it says to use a semicolon, you're going to use an equal sign, and you're going to work with your cards. On the test, are you going to have access to your card and your chart? Yes. Yes. Okay.